Hello, my awesome AP Chemers. Today we're going to start chapter 19, which is electrochemistry. So these are chemical reactions where electricity is involved. As always, make sure that you are reading your learning objectives. And you'll see after the reading objectives, you'll see a big box here that talks about electrochemical cells and electrolytic cells. So in this chapter, we're going to deal with two types of cells, and they're the exact opposite of each other. So electrochemical cells are spontaneous reactions that produce electricity. Electrolytic cells are non-spontaneous reactions that in order to get them to go, you have to add electricity to them. So it's very important in this chapter to know, which one are you referring to, electrochemical or electrolytic cells. But we're going to start all of this with a brief review of redox reactions, because redox reactions are the flow of are reactions where there's flow of electrons, and that's what electricity is, the flow of electrons. So we're going to start with talking about oxidation states rules. So remember, oxidation states or oxidation numbers are made-up numbers that we assign to each atom in a chemical reaction, and based on this oxidation state, as it changes from reactants to products, we can tell whether the reaction, whether that species has gained electrons or lost electrons, whether it was oxidized or reduced. So the oxidation state of an atom in an element in its natural free state is 0. So if I see, just sodium by itself, for example, then it's 0. Or if I see O2 by itself, it's 0. So whatever the natural state is of the element, in that case, the oxidation state of that element is 0. The second rule says oxidation states of monoatomic ion is the same as its charge. So if I see Na+, then +1 is the oxidation state of that sodium. If I see O with a 2-, then -2 is the oxidation state of that ion. The next rule says the oxidation state of oxygen in compounds is -2, except when it is a peroxide. Then it's -1. So in water, for example, H2O, the oxidation state of the oxygen here is -2, but in peroxide, which the most common peroxide that we know is hydrogen peroxide, here it is -1. So normally it's -2. Oxidation state of fluorine in compounds is -1. So if I have, for example, CuF, then it's -1. Next, the oxidation state of hydrogen is +1 in compounds with nonmetals. It is -1 with hydrides. So hydride means that you have a metal bonded to a hydrogen. So for example, in water, the hydrogen here will be +1 because it's bonded to a nonmetal. But when it's bonded to a metal, like LiH, for example, then here it would be -1. The sum of the oxidation states in a compound must equal to 0. So if I were to add up here the oxidation state of that copper and the oxidation state of that fluoride together, they should equal to 0. Same thing with the water. If I add up the oxidation state for 2 of those hydrogens and 1 oxygen, then it should equal to 0. So if it's a compound that's neutral, then when you add up the oxidation states of each of the different atoms in there, it should equal to 0. If it's not a compound, if it's not neutral, so if it's a polyatomic ion, then the sum of the oxidation states need to equal to its charge. So for example, if I have ammonium ion, NH4+, then if I add the oxidation state of that nitrogen plus 4 times the oxidation state of the hydrogens, that should equal to +1, which is the total charge. So let's practice figuring out the oxidation states for these. So we're going to start with Cu2O. So oxygen here is -2. Copper, there's no rule about it. However, knowing that the total needs to be 0 because it's neutral, because it's a compound, that makes each of the coppers +1. H2SO4, so we have a rule for hydrogen, it's +1. We don't have a rule for sulfur. We have a rule for oxygen. It's -2. And so to figure out that sulfur, you're going to say, well, I have 2 of the hydrogens, each are +1, plus X is my sulfur, plus 4 oxygens, each are -2. Altogether, that should equal a 0. And so that makes my sulfur +6 here. MnO4-, that's the permanganate ion. I don't have a rule for manganese, but I have a rule for oxygen, it's -2. So I say X, which is my manganese, plus 4 of my oxygens, each are -2. All together should equal to -1. That's the overall charge. And so that manganese is +7. Remember manganese +7, that's a purple color. That was my grape Kool-Aid at the beginning of the year. Dichromate ion, we don't have a rule for chromium. We have a rule for oxygen, it's -2. And so I'm going to say 2X, because I have 2 chromiums here, plus 7 oxygens, each are -2, should all equal to -2, because that's the total charge on the species. And so my chromium here is a +6. So each of the chromiums is a +6. So it's important to know the oxidation state so that you understand these redox reactions. So in a redox reaction, electrons are transferred. So these are reactions where electrons are transferred. So redox is short for reduction oxidation or oxidation reduction. And so 2 reactions actually happen simultaneously. We have the oxidation reaction and we have the reduction reaction. Let's start with reduction because I think it makes more sense in terms of its name. Reduction means you reduce the charge or the oxidation state. So if your charge goes down, that means you've underwent reduction. And remember that the charges go up or down because of electrons. Electrons are negatively charged. So in order for the charge to go down, it must have gained electrons. So reduction means gain of electrons. Remember, Leo goes grr. Leo the lion goes grr. So here's Leo the lion. And so Leo stands for loss of electrons is oxidation. Grr stands for gain of electrons is reduction. So when you gain electrons, your charge is reduced, and so that's reduction. Oxidation obviously is the opposite. So your charge is increased. Increase charge or the oxidation state. And so to do that, you must lose electrons because electrons are negative. So if you lose the negative, you become positive. So let's look at a reaction here. We have zinc plus lead ion yields zinc ion plus lead. So when you look at a reaction, in order to figure out if it's a redox reaction and what is happening, you assign oxidation states to every single atom in the reactants and in the products. So let's do that. Zinc here is 0 because it's an element in its natural state. Pb2 plus, here is +2 because it's a monoatomic ion. Zinc 2 plus again is +2 because it's a monoatomic ion. And then that lead is neutral and it's 0. So the 2 that have changed, zinc went from 0 to +2, lead went from +2 to 0. So for zinc, we went from 0 to +2. For lead, we went from +2 to 0. So I always ask myself, which one got reduced? Because again, the name for that makes more sense. So the one that got reduced, the one that went down in its charge would be the lead. It went from +2 to 0. So that's your reduction equation. So Pb2 plus going to neutral Pb, that's a reduction because you went from +2 to 0. The oxidation is the one that went up in charge, and so that would be the zinc. The zinc went from 0 to Zn2 plus. In order for the lead to get reduced, that means that it had to gain electrons, and in this case it gained 2 electrons. So Pb2 plus 2 electrons would yield neutral Pb. For the zinc to become oxidized, it has to lose electrons, and in this case we lost 2 electrons, so that I go from neutral zinc to zinc 2 plus. So my lead was reduced, it gained electrons. My zinc was oxidized, it lost 2 electrons, and so when you add it together, if you had both sides, the electrons cancel out and you get this overall reaction here.